All right, here we go. 1-5, day one of one. It's the only day. I think you can take a little bit of a breather. Here comes a dad joke. Decided to wear a bright t-shirt. Just to communicate brighter days ahead. We've had some tough lessons. You guys have been awesome working. And just want to say thank you for all your questions and hard work. But now, take a little breather, I think. So here we go. The good news here, the title is Solving Equations by Graphing. So there's a collective, not more graphing. Yeah, it never goes away. But our best friend, I don't know if you can read this, I can tell it's a little blurry and I wrote too small, but Desmos.com is your best friend. We're going to be using a lot of Desmos.com, so we're going to need our laptops. Graphing calculators are good, but Desmos.com is just phenomenal. I'll show you why. I'm going to do this one by hand, and just to show you why Desmos.com is our best friend. And here we go. So it says solve equations by graphing. Now, let's go really old school here for a second. Example one, solve this. If I said, hey guys, solve it, hopefully you go, I definitely don't need to graph that. So we're going to subtract 20, and now I'm going to go negative 3x is equal to negative 15, divide by negative 3, divide by negative 3, and I get 5. X is 5. Done. So what even is that? Well, it's your answer, but what is really going on? This section is going to help you understand what it is you're really doing. And here comes the new school. The new school is saying, okay, if negative 3x plus 20 equals 5, and I got to solve it by graphing, then I'm going to set this side equal to y, so I get y equals negative 3x plus 20, and I'm going to graph that. And if it equals this side, then I can set that also equal to 5, graph this, and find out where they intersect. Now, again, hold your horses. I know you're thinking, why would I ever do this? Wait for example 2. It'll make more sense when I get to example 2. Right now, I'm just kind of warming you up, hence the pre-lesson. So let's graph this first. As you can see, I've made a pretty hodgy-podgy, imperfect graph here, but hopefully we'll get the job done. So y equals 5. Remember, y equals 5 is going to be a horizontal line, 1, 2, 3, 4, 5, right there. But as you can see, my units go 2, 4, 6. So 5 is right here. And Desmos would do this in 2 seconds. I'm just trying to give you an idea of what's going on. So there's my graph of y equals 5. What about this one? I'll do this one in red. Hopefully that'll show up. Here's my y-intercept. As you can see, I cheated. I knew it was up there 20. So there it is, my y-intercept. What's this? It's my slope, negative 3 over 1. So I go down 3. Remember, these are chunks of 2. So 2 plus 1 is 3. And then I go right 1. Down 3. This is 2 over, so I'm only going to go halfway. Again, this is not perfect. But if I was to draw this in, it would come in like this, and it would hit right, again, not perfect, it would hit right here-ish, and then just keep going. So the question is, where is that? As you can see, graphing it by hand is is just welcoming imperfection. Desmos is perfect. But as you can see, we know our answer is x equals 5. So if we had to guess, we'd go, aha, x is 5, and then y is 5. So that's the point. So my answer is 5. X is 5, because that's the intersection point. But really, it's x equals 5, y equals 5. So I found an intersection point, 5, 5. But again, the problem only wanted us to find x. Remember that. So really, I'd go, oh, it looks like it intersects right at 5. So there's my answer. Okay. With that being said, I'm going to show you a more difficult one. Okay, so here's the more difficult one. Remember example 1, I looked at it and I'm like, I'm just going to solve for x just like I've been doing since who knows what grade. This one, good luck. Much easier to use graphing. In other words, if these two sides are equal, which they are, then what I need to do is I need to go y equals the left-hand side and y equals the right-hand side. Remember, the original problem only has x. So I'm just trying to find x. I know we're like, once we introduce y, you're thinking, oh, I got to find both of them. No, you're just going to find x because that's what we're trying to solve for. Very difficult to do as an equation, very simple to do using decimals. Now, so that's it for the pre-lesson as far as me doing stuff on the board. Now I'm going to take you over to my classroom computer and show you decimals. All right, so here we are, decimals.com, DESMOS.com. And all you got to do is type your equations in. So the first one that I'm going to type in is the absolute value of x minus 4. So here we go. Got to go to the bottom left-hand corner here to the keypad. Absolute value of x minus 4. Finish that off. And there it is. I'm going to get rid of this keyboard here. And that's the graph. Now, we're trying to find where it intersects with 1/2 x plus 1. So 1/2, I could have put 0.5. Now when the cursor's down here, I got to use my right arrow. If I put x in right now, it'll be 1/2x. I don't want that. So I'm going to slide over, slap that x in there, and then plus 1. Now look how cool this is. So the intersection point is right here. You can put your cursor over it. Don't forget what I said before I came over here. We're just trying to find x because the original equation only had x. So what's the x value? The x value is always the first one. Yeah, they're the same, 2 and 2. But this is my x, that's my y. They want us to find x. So x is 2. Now I want you guys to notice, though, these things collide up here a little bit again. So if I put my cursor on that intersection point, it tells me x is 10. Yes, the point is 10, 6, but they only want x, so x is 10. And x is 2. Those are our two answers for this one problem. Okay, example 3, bouncing back and forth, back to the board. Here's the math problem. Notice we only want x. You're going to be tempted to want to find x and y because you're going to introduce it. But let me show you something about this one. Back in Algebra 1, maybe even a little bit in geometry, you'd have to tackle something like this, and you'd go, oh, I remember these. I'm going to subtract x, add 2, subtract x, add 2. So we get x squared minus 5x plus 3 equals 0. You would try to factor it. Realize you can't factor the trinomial into two binomials. Is this ringing a bell? And then you go, oh, I can't. So I got to go negative b plus or minus the square root of b squared minus 4ac all over 2a. 1 is my a, negative 5 is my b, 3 is my c. Plug them in, and you're going to find your x's. And you're going to get some crazy answers, because that's what happens a lot of times with the quadratic formula. Now, that's not what the expectations are. I just want you to know there's a different way of doing it. Because let's say you're on an SAT, ACT, and you're not allowed to use, this is a part of the test where you can't use a graphing calculator or decimals. This is the way you would have to go. If you have questions about this technique, see me, but I'm getting paid the big bucks to show you this new technique. So, because they're equal, I can introduce the letter y. So y equals this stuff, the left-hand side. Y equals this stuff, the right-hand side. And now we can use decimals.com, our best friend. Back to my classroom computer. Okay, so the first one we're going to graph is our y equals x squared minus 4x plus 1. So x, and we got to square that. And then also, if I keep typing, it's going to include this stuff in the exponent. So I got to hit my right arrow to get her down there into the lower area there, minus 4x. It's continuing to help us out, and then plus 1. So there's the graph of that equation. Now, we're going to add the other one, x minus 2. Hopefully you guys are seeing how easy this is. And I'm going to zoom in just a little bit because that'll help me see my answers a little bit better. So I'm finding x, don't forget that. So 0.697, can you imagine doing this by hand and being expected to figure that out? It's not going to happen. 0.697 is one of my points of intersection. And then 4.303 is my other point of intersection. And that's as easy as it gets. Okay, slightly different brand of these kind of problems you're going to be dealing with are inequalities. Inequalities are greater than 0, less than 0, greater than or equal to, less than or equal to. Why aren't you doing this one on decimals then? Well, we're going to take a look at this and I'll have a better time explaining it here. There's no way I can draw on that computer screen, so this is why I brought it over here. So if we think about this as a graph, this portion, we would think, that is y equals x squared minus 4. Now the parent function is y equals x squared, if you remember all that stuff, which is right here. And yes, you definitely can use decimals to do all of this, but I got, again, I got to show you some things. But now we're going to drop that down 4 because that is my letter D. So I'm going to go 1, 2, 3, 4. That's where the vertex goes. And if you actually did it on decimals, you could clearly see that it goes through 2, 0 and negative 2, 0, which end up being very significant points. Let me get rid of this one. That's just going to cloud our thinking. And now I want you to think about this. Where is this graph? We're talking about x, but where is this graph greater than 0? Well, what that means is, where is that above the x-axis? Slightly different. In other words, that's another way of saying, where is y? Now notice, y equals this stuff. So it wants us to talk about where is y greater than 0. It's above the x-axis. So that would be strictly here and here, and here and here. Now this goes back to a domain lesson where we have to think, okay, where is this graph greater than above the x-axis? Well, if this keeps getting wider, it's going to go all the way from negative infinity all the way. Remember, this is negative 2, 0, and this is 2, 0. But right at that point, it would be on the x-axis, so it doesn't include negative 2. It gets there, but it doesn't include it. And we put parentheses around negative infinity all the time. And then also from here, that way. So where is this graph above the x-axis? Well, it starts at 2. That's our left-hand boundary. It doesn't include it because that actually is not above the x-axis. It's on it. And then all the way to infinity is where this graph is above the above the x-axis. So my final answer would be negative infinity, negative 2, and to infinity. And there you go. That's your answer for this problem, because that's the section of the graph, the domain, where the graph is above the x-axis. Keep that in mind. That finishes the pre-lesson, you guys.